Welcome to another science lesson. Today, we are going to look at science as a subject, particularly narrowing down to a branch of science called chemistry. And in that chemistry, as I mentioned in the first lesson we had, that we have special areas where experiments are done, and those special areas are called laboratory. So in the lab, which is a special area where experiments are done, particularly narrowing down to chemistry, we shall realize that these labs will obviously be different. And I want us to look at how special is a chemistry lab. What are the special materials, items, apparatus that can be found in a chemistry lab? How those items, apparatus work, and why do we think they are the best and not the others? How well we should use those apparatus? How well should we interpret the data gotten from the apparatus? And lastly, how to draw those apparatus? Because remember, after you have visited a lab, you have done an experiment. Remember, I'm talking about a chemistry lab. You have done that experiment. You have used certain apparatus. When you will be recording your observations, you may require to draw some of the setups. Remember, you are the one doing the experiment, but that knowledge you are getting is not just for you, it's for you and for others. So how will the other person who was not present when you are carrying out the experiment be able to understand what you have been doing? The only way the person will be able to understand what you have been doing is by looking at your data, which has been gotten from your observations. And this data must be showing where it came from, and it will be coming from an experiment which was set in a particular way using particular apparatus in a particular way. So because of that, we need also to know the standard way of drawing some of the apparatus. Some of the apparatus may look almost the same. So without a standard way of looking at how to draw them, then it may cause some confusion, which is not very good in science because confusion can cause death. No confusion at all when it comes to science, because we always want to get clean work and clean results. So, as we saw, that each area of study has its own type of lab. Our chemistry lab is mainly a lab that deals with the chemicals. And most of these chemicals, most of them, not all, but most of them are in liquid state. Most of them are in liquid state. Most of them are colored. Most of them are colored. And for these chemicals to be used, we will always, in most cases, require heat energy. So, because of heating, the apparatus must be made in a particular way so that we can handle the aspect of heat. We also need to know that as the reaction of this chemical is going on, you need to be able to observe. observation must be done. And one of the observation is using your eye. You have to see. If the material that you have is inside a container, and it is that material that is reacting, how will you be able to see if it were that I'm using such a material? It will be impossible. So we also have to look at that material in relation to, is it possible for one to make an observation? We also need to know that in chemistry, we are looking at accuracy. Accuracy. Remember, in the previous lesson, we talked about rules. And one of the rules, the very last rule I talked about, was to do with the drugs. That you cannot just access some drugs, but others you can easily access over the counter. Now, these drugs, you will be told, take this dosage. How? Why? Because accuracy was done at some point when the tablet was being prepared, that this tablet will be carrying this amount of this substance. So one needs to take maybe 10 of these in this span of time at a regular interval. Accuracy. So because of this accuracy, then we have to get measurement. So we have instruments or apparatus that are used for measurements. Measurements. These are the major areas as we are looking at the chemistry lab that we have always to remember. And lastly, over the same, we have to remember that we are talking about chemicals. And chemicals are dangerous if wrongly used. So lastly, we have to look at rules. Rules. So as you can see, I've very much insisted on this word rule. In the previous lesson, I talked about rules associated in the lab, associated with the lab, and rules associated with the products on the market. Here, I'm talking about rules associated with the chemistry lab. Not just now a lab, but a chemistry lab, which you and me must always follow at any particular moment. Now, I cannot proceed without us knowing the rules. Before a game starts, maybe you like cricket, rugby, football, whichever game. You cannot participate in that game without knowing the rules. Rules come first. So let's first of all look at rules associated with the chemistry lab before we look at any other thing, any other apparatus associated with the chemistry lab. So number one, let's look at rules. Rules in the chemistry lab. Now, going by what we mentioned, I mentioned earlier that we have to be having at least an apparatus to give us heat energy. Heat energy is given out by a flame. Heat energy is given out by a flame. And as you know, fire is a good servant. But when it decides to be a master, is a very bad master. So we have to be safe when it comes to flames. For the ladies or some gentlemen who may be having long hair, when you enter a lab, particularly a chemistry lab, make sure your hair is held from behind so that you don't have loose hair towards the front side. That is a material that can catch fire at any time. So you can imagine your hair on fire I'm sure it will not be a very good experience. So your hair must always be held from at the back. Number 2, over the same, you should not be having any loose clothing. We don't advise having a tie in a chemistry lab. That tie can cause a problem. Imagine having that good tie of yours hanging in your neck. Then you are having sulfuric acid with you there in a beaker, but you want to pick a certain item maybe just in front of you. You will at least stretch. As you are stretching, the tie will be entering somewhere else. So it enters that sulfuric acid without your knowledge. Then as you retreat back, the tie also retreats back. Why is it sticking? It will be sticking on your shirt, which is just on your stomach. And an acid can cause a very serious burn. Very, very serious. So with that loose cloth, you will have caused a very big problem. It can also apply to loose hands, clothing that have maybe loose clothing to do with the hand. So as you are handling, that loose clothing can easily soak itself in a chemical. Or maybe you are hitting something on a Bunsen burner. That loose clothing can easily catch fire. So that is to do with the rule pertaining loose clothing in the lab. The other issue is to do with the footwear. Footwear, never enter the lab with the just open foot. Remember, in the lab we have glasswares. We shall be talking about them, and we can easily encounter broken glasswares that can cause a very serious injury to your foot, or spillage of a chemical. Imagine of a case where you are heating a chemical on a Bunsen burner, accidentally it spills over and you have just a free foot exposed to that chemical, and probably that chemical is something like that sulfuric acid. You will get a serious burn that you may take a very long period to recover, and that is if you will recover. So please always enter the lab when fully covered with your foot and even all the other parts of your body, and that's why you should always be in a white coat, which is very good in covering you, and it is not loose in any way. Don't have a white coat that is loose. The other thing is to do with your eyes. Never perform an experiment with the naked eyes. Always have the glasses. We have the lab glasses that you have to put on, not like these ones of mine. But if they are not there, at least for me, I may be a little bit safe because partially my eye is covered. But for you maybe who is not having glasses, it is always good to cover your eyes. However, even me with these glasses, these ones are not enough. I need another cover which is wider. They are usually wider, so they will cover your eyes in a much better way for your safety when doing experiments. That is to do with the rules. Another rule is to do with if you want to get your way around the lab, how best should you do it? Never move by running. Never move in the lab by running, because you can imagine by running, maybe you want to get a certain item very fast. That getting very fast can make you get it very late. You can easily slide, knock something, knock an item, which can cause a very serious injury on your part. And having gotten the injury, I'm sure whatever you wanted to get, you will have gotten it much late. Or if, that is if you will get it, you may even never have to handle it anymore, because maybe the injury is so serious that you are now kind of told to do with the chemistry, bye-bye. The injury is too much for you, you will never proceed with the chemistry. We don't want such cases. So please be mindful on how you move around the lab. The other aspect is to do with how do you test chemicals in the lab. How do you test chemicals in the lab? The rule to do with the testing is, if it is a gas, don't smell it directly. It might be a dangerous gas, so you do the swirling bit so that you only get just a little bit of it and know what it is. Don't test by directly smelling on that particular substance. No, it is not allowed. You may be killing yourself without realizing. Another rule is to do with the heating. When heating, remember in the previous class we said that teamwork is important in science. So imagine you are in a group of 2, 3, 4 or 10 people working on something. Then here you are heating something, but the mouth of the item, the apparatus you are using, I will be giving out the names of those items, is facing towards one of your friends. Then as it is being heated, it spills out to your friend. Will you be happy? I'm sure not, because you will not be happy seeing your friend hurting, and it may be a very serious burn that can cause totally your friend being expelled from that class. For example, if the spillage is to do that acid going in the eyes of your friend, who may be knowingly or unknowingly didn't have eyeglasses to protect him or her, the eyes will have been destroyed, the eyesight not there, so which means science crossed for that particular individual. So make sure that whenever you are hitting, you hit in a proper manner, and also hold the apparatus using the correct apparatus for holding, as we shall be mentioning or going through the apparatus with the time. We also need to look at, in terms of the rules, when in the lab something serious has happened, an accident has happened, how do you report? Where do you report? It is a rule. Make sure when you go to the lab, in the lab you must be having a more knowledgeable individual in the lab, in the name of either a lab technician, a teacher, an instructor, or whoever. But that person must be knowledgeable enough to deal with any eventuality that takes place. More so the lab technician. They are always taught on how to deal with some emergencies that may happen when somebody is in the lab. Do some first aid before, maybe if it is a very serious one, you can go to the hospital. Without those individuals and something happens, I'm sure you may end up regretting doing the experiment when it was maybe a very good one to help humanity. Now, there are so many rules that I may not touch on all of them, but at least I have to also to touch on this one. There are signs that you have to know the meaning of those signs in the lab. There is a sign for hazard. There is a sign for flammable substances. Most of those ones. Flammable substances, or a sign to show hazard, dangerous substance. If you don't understand those signs, you may go somewhere in a lab where it hasn't been written in words. It is only written by virtue of that sign. So without your knowledge, you go use that substance in a wrong way. You may just end up hurting yourself, and just because of one simple thing, you don't know the rules pertaining those signs and what they mean. Just like in driving. If you go for driving, they will always teach you that this sign means this and this one means this. If you are a driver and you don't know those signs, then you are not a driver. In fact, driving is about the signs. Just making the machine move is not very important. Making the machine move on the road in the best way is what we call a good driver. That's the person we shall call a good driver, following the rules. Anyone can make the machine move, but not in the best way it's supposed to move on the road. So rules are very important everywhere, and rules are important in the chemistry lab, just like, as I've mentioned, explaining each one of them, how it can be either dangerous or important in your operation. Now, secondly, let's look at now the equipment. The equipment found in the lab. Equipment found in the lab. We look at the equipment found in the lab. Now this equipment, you remember I gave so many details of them. Can be used for heating, can be used for maybe measurement, and so on. So this equipment, they are categorized into various categories, and I will start with the equipment associated with the glassware. Equipment associated with the glassware. So there are so many glasswares we have. We have so many glasswares in the lab, and each glassware has a function to perform. The common glasswares we are going to see in a chemistry lab are the ones we normally use for testing, and that is a test tube. We have a test tube. This test tube almost looks like a boiling tube. Almost looks like a boiling tube. The only difference between these two is this one is smaller and this one is bigger by size. This one is smaller and this one is bigger by size. Now, having seen the test tube and the boiling tube as one of the glasswares, though now there are two, the other one is to do with the flasks, and we have several of them. One of it being conical flask. So to do the flasks, we have several. One of it is a conical flask. This is one of the glassware where reactions are done. Chemicals are mixed to react for one to see what is supposed to be gotten after the two or the three reagents have been mixed. However, it is not mainly used for heating, where maybe a reaction requires heating. But you may find a reaction requires heating. In that case, we use a different type of flask, what we call a round bottomed flask. We use a round bottomed flask. That one is essentially made as a flask, but to be involved or to be used in reagents that require probably heating for them to proceed well. The other flask we have is flat. So as you can see, it's just to give the difference between round and flat. So we have the flat bottomed flask. Flat bottomed flask. Now, maybe by shape it will be good we note this, because remember I said earlier that we have the agreed ways on how to draw these apparatus. The agreed ways to draw these apparatus. The test tube and the boiling tube is they are the same by appearance, is only that one is bigger than the other. Boiling tube is bigger than the test tube, but the shape is the same. For these flasks, the conical flask is having this shape, and it is normally calibrated. The conical flask is calibrated. Calibration means showing marks on how much volume the conical flask will be carrying. However, it is not the best in measurement of volume. You should not be using these to measure accurate volumes. It can only give you an estimation of the volume. The round bottomed flask is this way. That's the round bottomed flask, and they come in different sizes. Just like conical flask, we commonly have 100 and 250, but they can come in different sizes. So that's our round bottomed flask, and the flat one looks like round, only that it is flat at the bottom. Then at the bottom is a little bit flat. So that is our flat bottomed flask. So this is the standard way on how to draw those apparatus. We have flasks, and the flask we are having is conical flask, round bottomed flask, and a flat bottomed flask. Round and flat are commonly used in reagents that require a little bit of heating, but if it requires stronger heating, then you use round, not flat. But for conical flask, it requires reagents that only require room temperature reactions, conditions, and not heating. So those are the flasks. But now, you remember I mentioned something to do with the measurement. So there is another flask that I haven't mentioned here, and I need to mention it before I look at those other apparatus that are involved in measurement. And that is, we have it here as a flask. We call it volumetric flask. Volumetric flask. So this volumetric flask is a flask that is mainly used to measure volumes accurately. You don't use something like a conical flask. So the main function of a volumetric flask is to measure volumes. It is different from these others by virtue of appearance in terms of its neck. It has a very long neck, so that you can be able to read the meniscus. And it is flat at the bottom, so that it can be able to rest on the surface comfortably. And it comes in different sizes. 50, 100, 250, 500, 1000, 2000 cubic centimeters. So if you can take an example of maybe 250 cubic centimeters, volumetric flask. Now this mark you are seeing here, it is the point you use, or is the mark you use to show that the volume has reached to the volume you wanted by reading the lower point of the meniscus. You see a liquid in a tube, you will always see it kind of in a bend mode. So you make the lower reading. It is the lower reading that must be at that level of the mark. So if this is the meniscus, the reading should be at that point. So which means your eye level must be at that level, so that you see it at 90 degrees. I'm showing in mathematics. You must have learned this. 90 degrees. Look at it at 90 degrees. Don't look at it at this angle, that is from the top, or at this angle from the bottom. You will always get a wrong reading. Make sure you orientate the volumetric flask or whichever glassware apparatus you are using to measure volume. This is the correct direction at 90, so that you read at the lower point of the meniscus, not the upper part. This one is wrong. This one is correct. So those are the 4 flasks we have as part of the glasswares we shall be mentioning in our chemistry classes to come. The other apparatus we have, which are still glasswares, and they are mainly used for measurement of volume, is a measuring cylinder. Is a glassware, and this is how it is drawn. Now this measuring cylinder, remember, it is narrow. So for it to be stable, there are those that come permanently made to have a base, or those that will be having a plastic base, just to make them stand upright at a right angle. They are usually calibrated. There's a calibration, meaning that they come in different volumes, ranging from as small as 10 mils to as big as 1 liter. And even under special conditions, you may be forced to have even a much smaller or a bigger measuring cylinder. Than the ones I've just mentioned, ranging between 10 mils and 1,000 mils. We may have smaller or bigger than those ones. So these ones, or this one, is used to measure accurate volume of a substance, particularly liquids, just like the volumetric flask we saw. So here it can measure varied volumes, but volumetric flask only measures exact volumes. Another glassware that can be used is a pipette. It's a pipette. A pipette is a glassware to measure volume, but exact volumes of that particular solution. And this is how it looks like. Now, it is, at the bulb point, we normally have the volume written there, common ones being 25 cubic centimeters. 25 cubic centimeters. You can either suck it directly, just have your mouth here with your thumb and you get the volume out of it, but we don't encourage such, because in case you are dealing with a dangerous substance, if it gets into your mouth, it can cause a very serious harm. So we use what we call pipette suckers. You have a pipette sucker which will be fitted at this point. So you suck using that rubber apparatus, which will move the solution until it reaches at this point, whereby it has to follow that. Remember the meniscus, how to read it. So once it reaches at that point, then you will be sure the volume you are having is 25 cubic centimeter, and transfer it to wherever you want. You will have achieved the measurement you wanted. But this one is giving us fixed volume, 25. No more, no less. Just like volumetric flask. However, we also have another one that now can give us varied volumes, and that is a burette. We have a burette. A burette is also used in measurement of volume, but varied volumes. Varied volumes. It must always be at right angle. Then it has a clip. Now they come in different shapes. They also come in different manufacturing operation down here. There are those you can fit on a rubber, then have a clip on the rubber. There are those that will come already with that knob to open and close. So depending on the one you have, the operation is the same. It ranges from 0.0 to 50.0 cubic centimeters. So when reading it, you read from the top, not from the bottom, whereby the starting point, if it is at this point, and probably as you release the solution into, maybe let's call it a conical flask here, you have now your solution inside, and you stop here. You stop at that point, which is now shown by the meniscus. So this is the point you have stopped. How would you read that? When reading, you look at the lower point of the meniscus. The lower point of the meniscus, which is moving from 0.0 where you started from to the last point. Let's assume it is maybe 20.7. 20.7. You don't read it from the bottom, you read it from the top. If at all you didn't start from 0, maybe you started from maybe 5.9, then you will have to get where you started from. That's 5.9, stopped 20.7, then subtract 5.9 from 20.7 to know how much volume you have used. So this one gives us an easier time on how to measure volume in the lab. So these are the main apparatus that will be used in measurement of volumes in the lab of liquids. Measurement of volume in the lab, but particularly of liquids. As you know, in the lab, we have so many apparatus, so many of them. And I may not be able to list all the apparatus until maybe you visit a lab to see those apparatus. But I have to mention some main ones, like the ones I've just mentioned. Now in the lab, remember, the chemicals you'll be having, those that are in solid state, are always found in containers. How would you get the chemicals from those containers? How would you scoop? So we have what we use in the lab to scoop, and that one is called a spatula. Spatula is, it's not called a spoon, it's a spatula. And it is used in scooping chemicals in the lab. Scooping chemicals in the lab. You don't go in the lab with your spoon from home to go and scoop chemicals in the lab. That's wrong, because once you do that, it will mean that spoon remains in the lab, and which will be wrong. And again, your spoon will be too big. Spatula is so small. It is this size, and it is normally flat on one side, but this other side, it is a circular. So you can scoop either using this end or this other end, but it is roughly this size of the size which is used in scooping chemicals in the lab. The other thing is going back to our round bottomed flask. You are doing an experiment that involves heating, and maybe that experiment is not taking just a few seconds. It is taking minutes or even hours. We have experiments that can take hours and days. Will you be strong enough just to hold a round bottomed flask for that long? I'm sure not. So you need now a special hand. We don't call it a hand, we call it a retort stand. We call it a retort stand. We have a retort stand in the lab, and the retort stand is used to hold the apparatus in position. You arrange the apparatus as you wish, connect the apparatus as you wish, then to hold them in that position for as long as you want, then you use a retort stand. The retort stand has a base. It has a base, then a rod onto which a clamp is attached, and this clamp has a boss where you can now fix here any material you want. You can fix here even that round bottomed flask as you are doing your heating at that particular point for as long as you want. So this is an important apparatus in the lab, particularly chemistry lab, though it is also applicable in other labs because of its functionality of holding apparatus in position. You can use as many retort stands as you want in a particular experiment, depending on which type of apparatus and how many are they you are using to carry out the experiment you are doing. Probably there are so many that are connected together. The other one is as a stand. We also have another stand, what we call a tripod stand. Tripod stand. A tripod stand is a stand that has 3 legs. Has 3 legs and is triangular. So can I take this one to be our metallic frame? Then these are the legs of the tripod stand, and I'm using that to show that it is the other side. So this is our tripod stand. Now this tripod stand is not always used the way it is. You will always have something what you call a wire gauze. A wire gauze that is placed on top. It is rectangular in shape, so it will be put on top, and at the center of the wire gauze it has a material that is used to regulate the amount of heat being transmitted from the bottom to whatever you are trying to heat. Now this one is normally used when you have something to be heated but just being placed on top of the flame, but for a long period. Maybe you don't want to hold it, it will take long, or it will be too uncomfortable for you to hold, but you are doing it for a very long time. Then this is the arrangement you will use: a tripod stand and a wire gauze. Very important. So we have 2 stands. We have a retort stand and a tripod stand. Now, I've just mentioned something to do with the heating. Very important. We cannot do without heating in the lab. We cannot do without heating in the lab. So the main source of heat in the lab is a Bunsen burner. Source of heat in the lab. source of heat. Source of heat in the lab. Now, the source of heat is not just particularly heat. It is heat and flame. Remember, a flame is different from heat. But from the flame, we get the heat. But from the flame, we can also get some other things like light. Now, this Bunsen burner that is found in the lab is able to give two types of flames. The bright flame and the less bright flame. These two flames have also another characteristic in terms of the amount of heat they will produce. The amount of heat they will produce. So I will wish we start from that point on the type of flames, then we look at the Bunsen burner as an apparatus. So the types of flames we get are luminous and non-luminous flame. We have luminous and non-luminous flame. Luminous flame is yellow in color. It is yellow in color. That is a luminous flame. In addition, it is large in size. Luminous flame, yellow, large in size. It produces a lot of light. Produces a lot of light. In addition, it is sooty. So you will find that it is producing soot. These are just characteristics of a flame. Because of these characteristics, it produces less energy, less heat energy. Produce less heat energy. So which means it is not the best for heating. It is not the best for heating. Why is it that we don't encourage people to use luminous flame for heating? There are two main reasons. The one that is most important is produces less heat energy. But the second point is it produces soot. So you will find that your apparatus will darken because of the soot that will have been produced, making luminous flame not the best. But in case you are in a dark place and you want to see something, then this one comes out to be the best flame because it produces a lot of light and it is large enough to produce that light and feel comfortable at that point that was once dark, and now you can be able to see whatever you wanted to see. Now, the other flame is non-luminous. Non-luminous flame. Non-luminous flame is the opposite of the luminous flame. In one way or another, not directly. There are those that it is direct, but others can be described in a different way. So looking at color, here we saw luminous is yellow, non-luminous is blue in color. Blue in color. Luminous is large, non-luminous is small. But in addition to being small, it produces a roaring sound. When burning, you will get that roaring sound being produced to show that it is different from the luminous flame. In terms of light, produces less light. Less light. In terms of being sooty, it is not sooty. Not sooty. And in terms of heat energy, it produces a lot of heat energy. Produce a lot of heat energy. It produces a lot of heat energy. So this just to do a comparison of these two flames, because these are the flames you will be seeing commonly in the lab. Why say commonly in the lab? I've just said that luminous is not good. But why should you see it? You should be seeing it because whenever you are lighting a Bunsen burner, and I will mention that in detail later, whenever you are lighting a Bunsen burner, it must first of all come out as a luminous flame for you to do some regulation on it, as I will describe later, to get an unluminous flame. Secondly, if any flame is not in use and you haven't put it off, any flame that is not in use and not yet put off, it must be changed from non-luminous to luminous so that visibility can be there. You can easily tell here is a flame and this one is not a flame. But in blue form, some may not be very fast to identify it. And being that it is very hot, you can see the effect that it can cause. Maybe you are just leaning near the flame, you had not seen it. By the time you realize, I think screams will be all over, which will not be good. So any unused flame, but not yet put off, must be in luminous form. During lighting of the Bunsen burner must be done in non-luminous form. No, in luminous form and not in non-luminous form. But now, how do we form luminous or non-luminous flames from a Bunsen burner? This takes us to what is a Bunsen burner and how it works. So we look at Bunsen burner. Now Bunsen burner is the main source of heat energy in the lab. Most of the labs we have. This is the main source of energy. And we get that energy by burning a gas, what we call a lab gas, which is, it is having three common names. The gas that is normally used is we call it either lab gas, we can call it natural gas, we can call it methane gas. So any of these three names mean the same. Methane, you will understand it much better when you will be talking about another topic in chemistry, which is by the name organic chemistry, where you will understand how crude oil is usually worked on to get all the products that we normally get. And even where there are no crude oil, you may find natural gas coming out, and when it is tapped, that's the gas that is normally available in the lab to be used as either natural gas, as we have just mentioned, it's naturally coming out from the ground, or you call it methane, or you can call it lab gas. Now, this gas is gotten from a cylinder. You will be having a cylinder, gas cylinder, where through a rubber tubing, you will deliver the gas into a Bunsen burner. But where particularly do you deliver the gas to the Bunsen burner? So a Bunsen burner has these parts. It has the point that is resting on a table, what we call the base. And at that base is where we have a point of entry of this gas. So you fix the rubber tubing at that point, which is at the base. This is the base, and on that metallic base we have the inlet of the gas, which goes much deeper inside to a smaller point of exit, where, or what we call a jet. What we call a jet. So this jet releases this gas in small amounts at a higher pressure. Small amount at a higher pressure. Because of the high pressure, it means the gas can be thrown a little bit higher from the point of entry, which is at the jet. So it moves up. Then we have a space which we call an air hole. Air hole. Then from there we have now the outer part, which you call the chimney. We call it the chimney. Now, on this, at this air hole, we have something that can be rolled, such that it can be rolled to go down to close this air hole. I can do this to show the air hole, to close that air hole, or to open the air hole. So with this jet, can extend a little bit. So the gas goes out from that point to enter the chimney, and we have this one, what we call the collar. The collar is what you can roll down or up to open the air hole. So this air hole allows air currents to enter. Remember, in a combustion, you require oxygen. For burning to take place, you require oxygen. What is entering here is not oxygen. This is just natural gas. This is just natural gas, lab gas, methane. So for us to burn this natural gas, we require oxygen. Where do we get the oxygen? It enters through the air hole. Now, when putting off a Bunsen burner, never put it off when the air hole is open as it is. Make sure the collar will have been rolled down until you have now the collar down here to have now covered the air hole. In that case, the flame you will be having on top, the flame that you will be having on top will be a bigger flame, which is luminous. It will be a bigger flame which is luminous, very visible. However, when you open the air hole such that enough air is entering to mix with this natural gas to burn, the flame you will have will be smaller, roaring and steady, because this one will be flickering. The luminous flame flickers around, yellow in color, but this other one will be small and steady, blue in color. So what are we seeing? Luminous and non-luminous flames are created by just dancing around with the air hole. You close the air hole, you make the yellow flame, which is luminous. You open the air hole, enough air enters, then you form what you call non-luminous flame. This is the Bunsen burner. It has these areas, the chimney, where the flame burns on top of the chimney. We have the collar. The collar, it has now moved down. Here is the collar. The collar is the part that is used in covering, opening and closing the air hole to regulate on either forming luminous or non-luminous flame. We have the jet. The jet is here, where the gas enters into the chimney. The gas enters into the chimney from the jet in small amounts but at a high pressure, so that it burns on top of the chimney. If it doesn't come with a high pressure, it will burn on the jet, a condition we call striking back, and it is not a good one. Striking back. Striking back is the situation whereby instead of the flame burning on top of the chimney, it goes to burn on the jet. That shows the gas is not coming in with a lot of pressure. Then we have the base, which holds the Bunsen burner in position. Now, we have been looking at so many apparatus. I haven't mentioned all of them. A better view of these apparatus can only be done when you are in the lab, and also you will be able to encounter so many apparatus. When in the lab, you will get to know all of them. For now, that is enough. Thank you.